In this video, we're going to take a look at how we can determine how many diagonals an individual shape has. So we define diagonals as any line that crosses a given shape from vertex to vertex without overlapping on any of its sides. So an example, right, we all know that vertex is a geometric term for a corner where two lines meet. So we want to create a line that goes from vertex to vertex like such. Now, the exception is that we don't want a line to overlap any sides. What that means is if I was to draw another line, this would not be a diagonal. Even though it does go from vertex to vertex, it overlaps one of my sides. So, not a diagonal. So let me actually get rid of that line. Okay, so we see here the red line, that is one diagonal. And a property of a square is that it actually has two diagonals. There are two diagonals that go from vertex to vertex without overlapping any lines. Now on the previous slide, we were able to just draw how many lines, and we were able to see those pretty easily, but as we continue to progress through our shapes, it's going to get more and more difficult to determine how many diagonals there may actually be. So before we get to that point, I want to show you how we can use this formula right here to determine the number of diagonals. And the formula is n times n minus 3 divided by 2. Now n, as you can see down here, stands for the number of sides in this shape. So the very first thing you're going to do is you're going to fill in your formula for all the variables n. We'll keep going with blue here. All right, I see that there are 4 sides to this rectangle. So my formula now looks like 4 times 4 minus 3 divided by 2. Now, if we follow order of operations, we know that we have to address the parentheses first. So this becomes 4 times, and then in the parentheses, 4 minus 3, which is 1, divided by 2. Now let's address the numerator. 4 times 1 is 4, and we still have our divided by 2. And 4 divided by 2 is 2. So using our formula, I can calculate that there are 2 diagonals in a 4-sided rectangle. All rectangles are 4 sides. But here are those 2 diagonals from vertex to vertex without overlapping any of my sides. So while in a more basic shape such as a square or a rectangle, we can very easily see the 2 diagonals, when we get into more complex shapes like pentagons, octagons, and so on, we're going to have a much more difficult time, so the formula will be very helpful. Let's take a look at these 2 shapes, all right? Over here to the left, we have another 4-sided quadrilateral that's called a rhombus, right? It also kind of looks like a diamond, or sometimes the shape resembles a kite, but it is a rhombus as one of its terms. And over here we have a trapezoid, another 4-sided quadrilateral. Now, like our square and our rectangle, both of these have 4 sides. So I can actually use the formula n times n minus 3 divided by 2 one time to figure out the number of diagonals for both of these shapes, since they both have 4 sides. And just like our previous problem, since they both have 4 sides, it's 4 times 4 minus 3 divided by 2. Well, parentheses first, it becomes 4 times 4 minus 3 is 1 divided by 2. We can multiply. 4 times 1 is 4 divided by 2. And then 4 divided by 2 is 2. So just like the rectangle on the previous page and the square on the slide before that, both of these 4-sided shapes, these quadrilaterals, have 2 diagonals. And it's going to be true for any shape that has 4 sides. The first diagonal in the rhombus is actually vertical right here, vertex to vertex without overlapping any sides. The second one is horizontal. That really kind of makes it look like a kite, doesn't it? Then we can come over here to my trapezoid and do the same thing, vertex to vertex without overlapping a side, and vertex to vertex. Now remember, an example of something that would not be a diagonal would be vertex to vertex that also overlaps a side. That would not be a diagonal. Now what about a shape like this? This is a 5-sided shape called a pentagon. Pentagon has 5 sides. Now if I wasn't going to try and solve how many diagonals this had without using the formula, this is where it might start getting more complicated, because in a pentagon, each vertex has more than one diagonal it can connect to. This top vertex can connect down to the left, and it can connect down to the right. It can also, let me change colors here from green to yellow, this vertex can go straight across horizontally, but it can also come diagonally down to this corner. If I change colors yet again, this vertex, we already know, can go from here to here, but this green line is also already indicated from this diagonal. And let me change colors one more time. No, I'm actually out, because if you take a look, each corner, each vertex is going to 2 other vertex. So this is where it starts getting more complicated. And while yes, I still can figure this out without the formula, it is much simpler to use the formula. And again, the formula being the number of sides times the number of sides minus 3, all of that divided by 2. We said a pentagon has 5 sides, so it's 5 times 5 minus 3 divided by 2, right? Recall that we're going to solve for what's in the parentheses first, 5 minus 3. So we've got 5 times 2, because 5 minus 3 is 2, divided by 2. We can multiply next. 5 times 2 is 10, and 10 divided by 2 is 5. So a pentagon has 5 diagonals, and I can count them here. I'll actually go highlight them. All right, so here's 1, 2, 3, 4, and 5. So while I was able to find them all individually without using the formula is a sure bet on how to find the number of diagonals. What about a shape like this? A triangle. We all know triangles. Let's write it. Triangle. All right, that's a G. A triangle. Now we can use the same formula, number of sides times number of sides minus 3 divided by 2. Well, standard triangle, all triangles have 3 sides. 3 times 3 minus 3 divided by 2. Recall, we'll work on our parentheses first. 3 minus 3, which gets us 0. So 3 times 0 divided by 2. We can multiply next. 3 times 0 is 0, so 0 divided by 2. And 0 divided by 2 is 0, right? It's like saying here is a pizza that's cut into 2 pieces, and you ate none of them. How much pizza did you eat? 0. So a triangle actually has 0 diagonals. And that's because it is impossible within a triangle to connect 2 vertexes that are also not sides. If I went from this vertex to this vertex, I'm overlapping a side. Top vertex to this one on the left, I'm overlapping sides, right? Even if I tried the bottom, the left vertex to the right vertex, I'm overlapping sides. And because of that, you actually don't have any diagonals within a triangle.